This is the presentation for work package 4 of the EU-funded project, the RISE-6G. And the title of the work package is RIS for Enhanced Connectivity and Reliability. My name is Petar Popovsky, and I'm a professor at Aalborg University in Denmark, and I'm leader of work package 4. The other participants in this work package include CEA-Leti, NEC, NKOA from Greece, CNIT from Italy, CNRS from France, and University of Nottingham. So the main question we deal with within this work package is how to design and optimize RIS-based systems to provide enhanced connectivity for both legacy frequencies as well as the higher frequency bands that are going to be used in 6G wireless communications. And the target is to boost the signal-to-noise ratio and the multiplexing gains for various scenarios that involve single or multiple users, and improving the reliability and coverage for these systems. So there are multiple deliverables that need to be prepared within this work package. So here I'm showing the latest one that was delivered, which is related to multi-user techniques and connectivity for RIS-based communication and mobile edge computing. And the next one that will be delivered in June is deployment and control strategies for RIS-based connectivity, which is basically the final specifications of the control strategies and the deployment. So this work package has 4 tasks. The first one is related to network architectures and deployment strategies for enhanced connectivity. The second one is the fundamentals of multi-user network connectivity for RIS systems. Then the task 4.3 is design of actual multi-user techniques for RIS communications, meaning that dealing with actual protocols for communication, actual control signaling, and so on, while task 4.2 is more about building the right models, how to design these protocols. And then task 4.4 is related to mobile edge computing and multi-user techniques for RIS-empowered computing. So this work package has been very productive in terms of publications. So there were more than 70 publications, and 20 of them were involved into collaboration with the other work packages. So we have a map of interaction with the other work packages. The point of this work package is that it defines elements of the protocol and control signaling, and as such has to have input and interaction both with the scenarios and use cases, but also more importantly with the other 2 technical work packages, 3 basically work packages, which are related to modeling, design, and characterization of RIS, localization and sensing, which are 2 complementary use cases compared to communication. And then for work package 6 for enhanced sustainability and security. Finally, the inputs from this work package will be also valuable into the proof of concept developed in work package 7. So the role of RIS in communication is initially was for boosted communication and enhanced coverage. Then improving the spatial multiplexing capabilities. So we want to create a propagation environment that will eventually offer better spatial multiplexing capabilities, and then improving of the outage probability and the throughput of the users and their ergodic user rate, in enhancing the mobile edge computing and control and monitoring of the electromagnetic radiation, which is the link with work package 6. But as mentioned before, the control procedures and the protocols are also useful for the operations of localization and sensing, which are considered in another work package, work package 5. So the solution needs to be tailored to different types of RIS. So we can have a reflective RIS versus hybrid RIS, which could be semi-passive, or controlled by another network element, where we need explicit control signaling to configure the RIS, versus autonomous, which has a sensing or receiving capabilities and capable to autonomously adapt to the environment. So in that sense, the protocol and the control signaling requirements are quite different depending on the assumptions we have for the RIS. So a quick look at what the task have achieved so far. Task 4.1 has defined and analyzed deployment and architectural strategies for different RISE-empowered system. Then we were specifically focused on defining the control procedures for controlled and autonomous RISs. And we have provided a systematic description of the communication steps that needs to be taken, basically the protocol steps that needs to be taken if we have to include RIS into wireless infrastructure. Then the second task about the fundamentals of multi-user network connectivity, we have developed various active and passive beamforming strategies. Then we have also shown how to exploit frequency domain by having time-varying RIS surfaces. And then we have also shown a framework for self-optimization in autonomous RIS, which is capable to sense the environment and basically adjust its reflection coefficients autonomously to the propagated signals. Then in the task 4.3, we have defined the RIS-aided random access protocol. So we believe that this is one of the first random access protocol defined in the context of RIS. We have developed various channel estimation techniques and classical and machine learning based algorithms for RIS optimization in realistic environment conditions and realistic propagation. Then the last work package is related to mobile edge computing. So here we have shown how to jointly optimize communication and computation and how to configure the RIS with respect to certain tasks done in mobile edge computing. And a specific use case is adaptive federated learning, which is empowered by RIS. Thank you for your attention.